All right, let's jump right in. Today, we're going to follow a single messy piece of data on its incredible journey. We're going to see how it goes from total chaos into something an AI can actually understand and use. So let's trace the path, step by step.
So, have you ever really wondered about this? How does something like ChatGPT read a messy human email and actually get it? It's not just about reading the words, right? It's about understanding the feeling, the intent, the whole point of it all. That's the puzzle we're putting together today.
Okay, so first stop on this journey, we need to understand the lay of the land. Because in the digital world, you'll find data living in two completely different universes.
On one side, you've got your structured data. It's super neat. Think of a perfect spreadsheet, right? Everything's in a nice, tidy box. Computers, they absolutely love this stuff. But then, there's the other side, unstructured data. This is the wild stuff. Emails, PDFs, chats, all that human conversation. It's messy, it's unpredictable, and it's almost everything.
And here's the kicker. Most of the data out there, like over 80% of it, is that messy, unstructured kind. This is the raw clay that AI has to work with. So our entire story today is about this big transformation. How do you take that lump of clay and sculpt it into something, well, intelligent?
Okay, so we've got our raw data. Now what? Well, the first thing it has to do is go through a kind of data boot camp. You can't just feed this messy information straight to an AI. Nope, it's got to get whipped into shape first.
And this boot camp really has two main phases every piece of data has to pass: data cleaning and normalization. Let's dig into what those actually are.
Data cleaning is pretty much exactly what it sounds like. It's the first big cleanup. We're talking about deleting duplicate entries, fixing annoying typos, and getting rid of any corrupted bits. You got to clear out all the garbage before you can find the good stuff.
All right, after the data's clean, it has to be consistent. That's where normalization comes in. It's all about making sure everything's in the same format. Think about dates. To you and me, October 5th, 2023 and 10/5/23 are obviously the same thing. But to a computer, they're totally different. Normalization fixes that, so the AI is always comparing apples to apples.
Okay, so our data is now clean, it's consistent, but it's still just a bunch of words. Now we get to the really, really cool part. How do we teach an AI what this stuff actually means? Well, it starts with something called data labeling. This is where we humans have to step in and play teacher for a bit. We basically take a piece of data and add a little tag to it, a label, to give it some context. It's like pointing at an email and telling the AI, hey, just so you know, this one's a complaint, or this review over here, that's positive feedback.
So, for example, that angry customer email is no longer just a random wall of text. Once we tag it with labels like negative feedback and billing issue, we've given it layers of meaning. And that's huge, because now the AI can start to recognize what patterns go with those kinds of labels.
But here's the thing. Even with labels, an AI can't really do anything with words. It doesn't speak English. It speaks math. It needs numbers. And this is where the real magic happens. It's a step called embedding. This is how we translate human words into a string of numbers that somehow actually captures their meaning.
Okay, the best way to wrap your head around this is with an analogy. Picture a giant, invisible map. Let's call it a map of meaning. On this map, every single word has its own unique location, kind of like a GPS coordinate. So words that mean similar things, like king and queen, are plotted really close to each other. But words that are totally unrelated, like king and, cabbage, are miles and miles apart.
So what does that actually look like? Well, a word like buggy, from a software review, gets turned into a long list of numbers. That's called a vector. And that vector is its GPS coordinate on our map of meaning. This is the language that AIs actually speak.
All right, so now all our words and concepts have been turned into these powerful numerical coordinates. That's awesome. But where do we store all of them? You can't just dump them in a regular spreadsheet. We need a special kind of memory, one built specifically for this new language. And that special system is called a vector database. You can think of it as the AI's long-term memory. It's basically a superpowered library designed to do one thing and one thing only: store and search through millions or even billions of these meaning coordinates at lightning speed. And this is the real game changer. With a vector database, the AI isn't just doing a simple keyword search anymore. It's searching for meaning. It looks for the closest neighbors on that map of meaning we talked about, so it can find ideas that are conceptually similar even if they don't use the exact same words. It's pretty incredible. And just like that, our data's journey is pretty much complete. So let's just pause for a second and look back at the incredible transformation that we've just watched happen.
I mean, think about it. We started with just a messy, raw, chaotic email. We sent it to boot camp to get cleaned up and standardized. Then we gave it some context with human labels. We translated it into the language of math by creating an embedding. And finally, we stored that mathematical meaning in a special vectored database where it's ready and waiting to be understood.
So, what's the end result of all this? That confusing jumble of words we started with? It's not just data anymore. It has become a piece of searchable, understandable intelligence that a machine can actually use to find patterns, answer our questions, and give us insights we never would have seen before.
And all of this leaves us with one really big final thought. For the first time, we have a clear system for teaching machines to understand not just our words, but our actual meaning. The technology is here. It works. So the big question isn't, can they understand us anymore? The question is, what are we going to ask them to do next?